Children, let's now move on to sums where we need to find out some values of angles. So we can say that these are numerical sums where some values are supposed to be found out. So what is there now in this particular question? Let's see. In the given semicircle with center O, now given to me there is a semicircle with center O, I shall say AB is a diameter. What makes me say that? Any chord passing through the center of the circle has to be the diameter. So we'll claim AB to be the diameter. So in the given semicircle with center O, tangent at point D. Okay, so we have tangent at point D meets AB produced at C. So on extending AB, when they say produce means on extension of AB. So on extending AB, the tangent at D meet at point C. If measure angle DAB is 28 given to us, measure angle DAB is 28 given to us, we are supposed to find out what is DBA, DBA, this one, and what is BDC, BDC, this one. So two values is what we are supposed to find out. We have been given one value. Let's start with our solution. So now when we start with our solution, we always write down whatever is given to us. So what value is given to us? The value which is given to us is measure angle DAB. Measure angle DAB is 28 degree. This is my equation number 1 given. This is my equation number 1 given. Now what? With this said and done, we just have to tell ourselves, which we have told while reading the question. What? Sir, AB is a diameter. So if AB is a diameter, what is angle ADB turning out to be? Measure angle ADB turns out to be 90 degree. Reason? Angle in semicircle. Reason? Angles in semicircle. So we shall say, since segment AB is the diameter, segment AB is the diameter, therefore measure angle ADB is 90 degree. Measure angle ADB is 90 degree. So let's say this angle is 90 degree. Reason? Angle in semicircle. Angle in semicircle. Angle in semicircle. With this said and done, what we are supposed to do now? We need to focus in triangle ADB. Now when I say in triangle ADB, this angle is given to us as 28. This is just now we found out as 90. Can't I get the value of this one with the help of angle sum property of triangle? So many must have calculated by working out an angle sum property, and they must have calculated by this time. The value turns out to be 62. The value turns out to be 62. The value of measure angle DBA turns out to be 62. We'll work out the same here. In triangle ADB, measure angle ADB plus measure angle DAB plus measure angle DBA is equals to 180, is equals to 180 degree. One can say angle sum property, or one can also say sum of measures of all angles in a triangle is 180. Angle sum property for triangle. Angle sum property for triangle. What next? On substituting the values of ADB as 90, DBA as 28, plus measure angle DBA, DAB is 28, sorry, 180. From where did I get the values? From 1 and 2. From 1 and 2. Measure angle DBA turns out to be 62 degree. On subtracting 90 and 28 from 180, what value of DBA turns out to be? 62. What next? Now I'm going to give you solution for BDC. Mind you, I shall provide you two solutions. Right? One is the shortest and one is bit, you can say, lengthy. Not lengthy that enough, but we'll be adding a couple of steps. We'll follow the shortest one so that you learn something that how to apply that particular theorem, and I shall give you the second solution orally also in this particular slide. So in order to get BDC, we'll work out in this way. Sir, is DC tangent at point D? Indeed, yes, it's given to us. DC is tangent at point D. So what is angle BDC working out to be? Angle BDC looks like to be a tangent secant angle, a tangent secant angle. Moreover, what is angle DAB looking out to be? Angle DAB looks out to be an inscribed angle. So if we have an inscribed angle, if we have a tangent secant angle, we have learned everything in our previous theory lectures. We have learned that what it should come, it should be angles in alternate segment. It should be angles in alternate segment. Still there are many who are thinking that, sir, how is it angles in alternate segment? The reason behind that is you have always visualized a complete circle, and what you can see right now is semicircle. Not an issue. You can always visualize. You can always visualize. So visualize that there is a circle. Visualize that there is a circle now. Now is it possible from your end to visualize, okay, this is an inscribed angle and this is a tangent secant angle? So we are done. We are done. So now what is it? I'm writing with a different marker to make you understand what we are making use of. I'll give you second solution also. What is it? Measure angle. Or you can say angle BDC. BDC is congruent to angle DAB. DAB. BDC DAB. Equation number 3. Reason, angles in alternate segment. Angles in alternate segment. Angles in alternate segment. We already have DAB, 28. So shall I say from equation 1 and 3, from equation 1 and 3, measure angle BDC. BDC works out to be 28 degree. BDC works out to be 28 degree. Our sum is done, mind you. We are done with our sum. We wanted to find out DBA, which is 62. We wanted to find out BDC, which is now 28. So we are done with our sum. But as I stated a minute back, I'm going to give you one more solution for BDC. What's that? So what is given to us? What is given to us? That is ODC, or rather DC is a tangent at point D. So if DC were to be a tangent at point D, what is this entire angle turning out to be? This angle, children, will this angle be 90? Reason, radius is perpendicular to tangent. Radius is perpendicular to tangent. Moreover, in triangle DOB, can I say it is OD congruent to OB, radii of same circle? So what type of triangle DOB looks like? It's an isosceles triangle. Since it's an isosceles triangle, this angle and this angle will be the same, right? Base angles of isosceles triangle. But sir, this is already we found out as 62. So if this is 62, even this is also 62. Now what angle we want? We want BDC. Can I say BDC is nothing but ODC minus ODB? 90 minus 62, answer is 28. 90 minus 62, answer is 28. That is also the second way to find out. Now here we have not made use of angles in alternate segment. We went with a bit lengthy way. We made use of radius perpendicular to tangent, therefore 90, then an isosceles triangle theorem, and then on subtracting we got the values. Children, I would like to say one thing. In sums where we need to find out, sums in circles and tangents and intersecting chords, sums on circles and tangents and intersecting chords, there will be multiple answers to a particular question. And what type of questions, sir? Where we need to find out certain angles. Children, the more you applied the concept, the more you have the answers. That many answers you can have. At times, some answers are small, some are lengthy. But what matters is getting the answer. So I've shown you here, as you work on more and more, try to get more answers. Why? You'll be expanding your thinking abilities in circle and tangents and intersecting chord. Quite simple this sum was, right?